Whether food processing provides additional explanatory power to current knowledge on the influence of specific foods and macronutrients on human health is arguably the most pressing question in contemporary nutrition science. Two opposing positions broadly define the debate. The first holds that processing per se, typically defined by the NOVA classification system and ultra-processed foods in particular, explains the associations between modern Western diets and long-term cardiometabolic and cancer disease risk. The second argument posits that the categorization of ultra-processed foods is poorly defined, encompasses heterogeneous foods with varying impacts on human health, and really serves as a proxy for other dietary factors associated with adverse health outcomes such as saturated fat and added sugars. Residential metabolic ward studies have found that very high ultra-processed food diets result in greater ad libitum energy intake and weight gain compared to minimally processed food diets. However, factors such as food energy density, eating rate, and food texture may explain such effects. One open question regarding ultra-processed foods relates to the proxy issue and the varying quality of foods captured within this definition. If diets differing in processing were similar in their overall healthfulness, judged by traditional measures of diet quality, would there be any difference in relevant outcomes? Now, to answer that question, we can turn to this fascinating paper published last year by Dicken and colleagues, the UPDATE trial, which was a randomized crossover and controlled feeding study conducted in the United Kingdom. Participants consumed two diets, each lasted 8 weeks, with a 4-week washout period separating the two diet periods. So participants either consumed a minimally processed food diet first, with an average of 82% minimally processed foods, following UK national dietary guidelines, and then consumed an ultra-processed food diet, which comprised 90% ultra-processed foods, but also followed UK national dietary guidance. As participants were randomized to the order of intervention, they either started with the minimally processed diet and crossed to the ultra-processed diet, or started with the ultra-processed diet and crossed over to the minimally processed diet. Diets were otherwise matched for macronutrients, and all meals, snacks, and beverages were fully provided to the participants and prepared by the research team. The primary outcome was the percentage weight change from baseline to 8 weeks on each diet, and obviously between group comparisons for the minimally processed and ultra-processed diets. Secondary outcomes included a range of cardiometabolic risk factors, body composition measures, and subjective appetite measures between the two diets. The results were reported as mean differences in the unit of measurement with 95% confidence intervals, and Cohen's d measures of effect size were also reported for certain outcomes, with 0.2, 0.5, and 0.8 considered small, moderate, and large effect sizes respectively. Now, as far as the results, there were 55 participants that were randomized, 28 to the minimally processed followed by ultra-processed food order, and 27 to the inverse sequence. The average age of participants was around 43 years, 91% were female, and 65% were of white ethnicity. The average baseline BMI was 32.7 kilograms per meter squared, so in the class 1 obesity range. Absolute body weight was 89.4 kilograms. And habitual ultra-processed food intake at baseline was 67% of the participants' total daily energy intake. For the primary outcome of percent weight change, body weight decreased by 2.06% during the minimally processed diet and by 1.05% during the ultra-processed food diet. Thus, the percent weight change between group difference was 1.01% in the minimally processed group compared to the ultra-processed group. This corresponded to a small to moderate effect size with a Cohen's d effect size of 0.48. For secondary outcome measures, weight decreased by 1.84 kilograms on the minimally processed food diet compared to a decrease of 0.88 on the ultra-processed food diet, which again, a significant between-group difference of 0.96 kilograms greater weight loss on the minimally processed compared to the ultra-processed food diet. Fat mass decreased significantly on the minimally processed food diet compared to the ultra-processed food diet, with a between-group difference of 0.98 kilograms greater fat mass loss in the minimally processed diet, and fat-free mass and muscle mass showed no significant difference between the two diets. Now, in relation to secondary cardiometabolic outcomes, triglycerides decreased more on the minimally processed food diet by 0.25 millimole per liter compared to the ultra-processed food diet. But correspondingly, LDL cholesterol decreased by 0.25 millimole per liter on the ultra-processed food diet compared to the minimally processed food diet. Other cardiometabolic risk factors, including total cholesterol, HDL cholesterol, fasting glucose, HbA1c, blood glucose, and C-reactive protein as a marker of systemic inflammation, showed no significant differences between the two diets. In terms of secondary subjective appetite outcomes, overall craving control, and specifically craving for savory food and difficulty resisting craved food, improved in both diet groups, but with significantly greater magnitudes of improvement in those scores in the minimally processed diet group compared to the ultra-processed diet group. Now, as far as the strengths and limitations of the study go, the study has several strengths, including the pre-registered protocol, and the published paper is consistent with the pre-registered trial protocol. The aims, objectives, and primary and secondary outcomes of the study were all clearly delineated. The major strength of the trial, however, is that both diets met UK national dietary recommendations for macronutrients, including fibre, sodium, and the 5-a-day recommendation for fruits and vegetables, thus differing primarily in the proportions of minimally processed and ultra-processed foods in the respective diets, providing a strong contrast in that exposure. The crossover design meant that all the participants served as their own control, and the effects of the diets were based on within-person comparisons, minimizing potential inter-individual variation in response. All foods were also provided to participants using commercially available products, increasing the internal validity of the study while maintaining ecological validity for the UK food supply. The study does have several limitations of note. The first is that the sample size was almost entirely female and predominantly of white ethnicity, with a high level of education attainment, and thus limiting the generalizability of the results beyond these demographics. While the diets were well matched overall, another factor limiting generalizability is the 90% ultra-processed food intake, where average intakes in the UK population range from 40 to 60%. It would be interesting to see whether the observed differences in the present study would hold at representative levels of ultra-processed food intake in the diet. Another important, crucial factor is that despite the excellent efforts to match the diets, energy density was greater on the ultra-processed food diet compared to the minimally processed food diet. And this is a factor that likely could have explained potential differences, for example, in the weight loss observed, weight loss being a function of energy intake and the magnitude of an achieved energy deficit. The final limitation is that despite the washout period between diet phases, there were clear treatment order effects observed, suggesting that the order of the diets influenced those outcomes. We'll come back to that point in our critique in due course. Before we get there, though, as we noted, a crucial strength of the present study was constructing both diets to reflect UK national dietary recommendations, but with contrasting levels of ultra-processed foods in the respective diets. In the minimally processed diet, ultra-processed foods constituted about 1.7% of foods, while in the ultra-processed diet, minimally processed foods comprised just 3.1% of foods. Assuming compliance with the diets, the dietary recommendations for saturated fat, salt, fiber, sugar, and the 5-a-day fruits and vegetables recommendation all appear to have been achieved. The major distinction between the diets, however, appears to be in total energy intake. Self-reported daily energy intake decreased by 503 calories on the minimally processed diet compared to 289 calories per day on average on the ultra-processed diet, a between-group difference of 327 calories lower on the minimally processed diet compared to the ultra-processed diet. Based on prior research, this likely reflects large differences in ultra-processed foods between diets. However, we are still left wondering whether processing per se is the relevant factor influencing energy intake. It's possible that other factors, such as the aforementioned difference in energy density as a primary factor distinguishing the diets, and other factors such as textual and sensory differences between the foods, may have influenced eating rate and energy intake between the diets, and consequently outcomes related to weight loss. Now let's come back to that point about sequence effects. One of the assumptions of crossover trials is that the treatment periods are independent of each other, so as to provide between-group comparisons that are uncontaminated by the order of the treatments, in this case, the order of the respective diets. The present study did find significant effects of treatment order, which we can see depicted in the figure from the paper here. When the minimally processed diet or the ultra-processed foods diet were consumed first, the minimally processed diet resulted in greater percent weight change by 1.7% compared to the ultra-processed foods diet. However, when the minimally processed or ultra-processed food diet were consumed second, the percent weight change in both diet groups was relatively similar, a decrease of 1.37 during the minimally processed diet and 1.34 during the ultra-processed diet. Thus, overall, the differences between the diets were driven by the first diet period. This finding tempers the persuasiveness of the differences in weight loss observed, which were not replicated in the second diet period. It suggests that individuals not meeting UK dietary guidelines at baseline and with a relatively high ultra-processed food intake at baseline, simply improving diet elicits favorable outcomes, at least in the short term. Now, as far as the wider relevance of a trial like this goes, the authors do deserve credit for the strong design and execution of the trial, which provided an important addition to the evidence by comparing ultra-processed to minimally processed foods diet in the context of national dietary guideline recommendations for macronutrients and fruits and vegetables intake. In the translation of research in the public square, however, these big splash studies can often generate a relatively uncritical reception of the outcomes, and scrutinizing the trial's outcomes leaves a somewhat unpersuasive picture. Starting with the primary outcome of percent weight change, a 1% overall between-group difference is hardly persuasive, with also other weight-related differences of a similarly negligible magnitude from a clinical relevance standpoint rather than just statistically significant standpoint. The effect observed for some lipid risk factors, with the minimally processed diet decreasing triglycerides while the ultra-processed diet resulted in a significant decrease in LDL cholesterol, were the most clinically meaningful differences between the diets. But this is also hardly a persuasive case against ultra-processed foods, and the reason why the minimally processed foods diet decreased triglycerides but the ultra-processed food diet decreased LDL cholesterol can only be speculated upon. In addition, all other relevant cardiometabolic risk factors showed no significant differences between groups. Most significant differences were thus observed for body composition, but differences in energy intake correlated with the changes in body composition measures. The latter point may be the finding of most utility, as one consistent finding in the limited body of controlled feeding studies of ultra-processed foods to date has been an ad libitum increase in energy intake on very high ultra-processed food diets. Yet it may be that other sensory properties of ultra-processed foods, rather than processing alone, explain such an increase in energy intake. However, the present study, as with other residential controlled feeding studies, had ultra-processed food contents of 90% or over of daily food intake at more habitual levels of intake. Would the impact on energy intake still be evident? This is something for future research to explore. The rigorous design of the present study permits a conclusion that, in a free living context, neither an ad libitum minimally processed nor ultra-processed food predominant diet prevents weight loss, although a minimally processed food diet may result in lower energy intake and improved body composition to a greater extent than a diet heavily reliant on ultra-processed foods. So how might we think about the application of a study like this? Well, the authors suggest that if the weight loss trajectories in the study were maintained over 1 year, this would result in weight loss of 9 to 13% and 4 to 5% on the minimally and ultra-processed food diets, respectively. This is a gratuitous deductive step, as sustaining weight loss over that long and with that trajectory is unlikely. Another interpretation would be that improving diet quality can be achieved with higher ultra-processed food intakes, as can weight loss. But comprising a diet of 90% ultra-processed foods may not be ideal for body composition measures beyond crude weight changes. If you enjoy this, please like and subscribe below and consider sharing it with someone that you might think would enjoy these kinds of breakdowns. Thank you.